Today we're going to look at how angles and sides of triangles affect each other and control each other. What I mean by that is I'm looking at a triangle right now and I see all the angles are measured for me and all their side lengths are also shown. Side AB is 7.18 centimeters. I want to change angle A. Unfortunately, with this program, I can't just take the side and move it. It's going to end up moving the whole triangle. So what I'm going to do to change angle A is actually move point C. You'll see when I do that, that's going to cause the other angles to change. But my focus, keep in mind, is on angle A. Right now, I'm going to make angle A smaller. And so I'm moving it in. Angle A is now smaller. Well, I could also make angle A bigger. I'm going to do that by moving point C again. Do you notice that when angle A is changing, it's actually forcing this side to change as well? So if this 73.8 degrees is changing, if I make that larger, the 73.8 larger, it makes this side get farther apart. If I'm going to bring this point in, then this side is going to be shorter. So changing an angle affects changing the opposite side. That would be true, let's say, for side AB. If I change side AB, it's going to affect angle C. Well, one way I can demonstrate on that is actually to grab a different point. I'm going to make angle C smaller, so watch angle C, 79.6, is going to get smaller. And when I'm doing that, it's causing this side, 5.52, to also get smaller. If I want to make this side bigger or this angle bigger, I could do that by just moving this point. And this side has gotten larger and that angle has gotten larger as well. So sides and angles affect each other. A side that is opposite an angle will affect each other. I want to look at this a little more specifically, though, not just about them affecting each other, but how they affect each other. We're going to be looking at page 7 of our notes. What I want you to do is get out your notes, go to page 7, and when you're ready, unpause this video. So pause this right now until you're ready to go on page 7. So I have this picture and this chart, and in the chart we're looking for the largest, middle, and smallest angles, as well as the sides. Let's start off with the angles. Look at these angles. It looks like 2 of them are given to me. I'm going to have to figure out this third one and fill in the top line of the chart. So pause this, and when you're ready, see if you got the right answers. Did you put them in this order? Or instead of using the degrees, did you put in the letters? I'm actually going to be more interested in these letters, and in just a little bit you'll see why. It's going to help us come up with a pattern. And when I talk about these letters, capital B being this angle, capital A being this angle, and C being this angle, and then I want to reference the sides, do you remember that instead of calling this side AC, we could actually call it side lowercase b? So this side right here could be referenced as lowercase b. What would that make this side? We could call it BC. What else could we call it? Were you thinking A? So this could be called side C. With that in mind, instead of putting the numbers into this table right here, will you put the letters in? And when you're ready, unpause this video. So I hope you have the same order that I'm going to have. 7.5 is the longest side here, so side B would be the longest side. And then if I go in order, A is the next number at 6 centimeters, and 4.5 is representing C. Do you happen to notice that the angles and their sides are in the same order? That will always be true in any triangle. It doesn't matter if it's a right triangle. That would be off of angles. Doesn't matter if it's a scalene triangle. That would be off of sides. That will be true in any triangle. So with that in mind, and keeping in mind that right now we're talking about sides, naming them with one letter, Go to the next page, and when you are done with this chart, go show it to your teacher.